this video, we are going to make the MakeCNC.com business card holder. This is one of 5 projects that we've partnered with MakeCNC on. And as an owner of a STEPCRAFT CNC machine, you can receive these files for absolutely free for your own use. And this is a great way for you to get started with your new CNC system. For those of you who have not heard of MakeCNC.com, I would recommend checking them out. They have literally thousands of different puzzle projects that you can download and cut out on your machine. So this is called the cat head card holder, and it's comprised of 5 pieces. It's a pretty simple project, so this is really a beginner. This would be a great first project for somebody as soon as you get your machine up and running. They have the files in 2 different formats. You can get them in a CorelDRAW format as well as a standard DXF, which is what we're going to use in this video. You can also get them in both 3mm and 1/8 inch scales. So I'll talk to you a little bit more about scale in a little while, but for right now, we are going to be concentrating on the 1/8 inch scale version of the DXF file. So if you scroll down, every project that you get from MakeCNC comes with this really nice digital instruction manual that's full color with nice photos. And you can see here as I scroll through, these are the 5 pieces that we're going to be cutting out on the CNC machine. And here is the assembly document that shows you how everything goes together, and you use glue to attach them. And this is a side view of the same business card holder. So it's a really cool project. It's simple, but it does give you a good overview on how to use some basic functionality and importing DXF files into Vectric, and how to output the G code so you can run this project on your CNC. Now, one thing that's important to notice on this is a puzzle project, and all the MakeCNC puzzles have these kind of tongue and groove and keyways that they use. So this front panel has this tab that's down here, and then the bottom panel, if we go to this page, so the bottom panel has this notch out here, so this tab fits in this notch. Now, one thing that we're going to have to deal with is the fact that with a CNC machine, we're using round tools, which means we can't get a perfect inside corner. If you were cutting this with a laser, you could get a square inside corner, but with a CNC machine, you're always using a round tool. Even if it's just a small 1/16 inch end mill, you're still going to have a radius in the corner. So let's dive right in, and I'll explain to you how to do this project. Okay, so the first thing we need to do is open up Cut2D. Now, it's important to mention I'm using Cut2D Desktop here because you really don't need Vectric's top-of-the-line programs in order to make this project. However, if you have VCarve, VCarve Pro, Aspire, that you can do the same thing. All the same functionality appears. It's just Cut2D is the base program that we sell, and the desktop version has the 25 by 25 inch limitation. But again, for this project, it's perfect. So it's a great program, and we're gonna jump right in here, and I'll show you how to do this. So the first thing we're going to do is create a new file. Now, I went and bought a piece of wood from Michael's Crafts. It's from Revel. It's in their hobby section where they'll have like balsa wood sticks and plywood, etc. And I bought a piece that was 12 inches by 24 inches, and they label it as 1 inch thick. So this project's not very big, so I've set it up for the 12 inch width. I've set my height up to be 6 inches. And I put 125 in as my thickness, so 1/8 of an inch. This is a single-sided job, and I'm going to position my Z0. This is where the tip of the end mill is going to touch against the top of the material for its 0 position. You can do either the top of the material or the machine bed. For this particular project, we're going to use the material surface. The XY datum, what that means is that's the position on the XY on the machine where you will put your end mill and 0 out UCCNC. So that is going to be your starting reference point, and it's denoted by this red square right here on the lower left corner of the screen. If I move it to the center, you'll see everything changes and the red square moves to the center. For this particular application, we're going to leave the lower left corner, and this will ensure that we know our project is going to go to the right and up. So we're going to minimize waste on the left side rather than trying to center it in the middle, which is going to give us more waste around the outside. So once we set that up, we're just going to click OK. Now the first thing we need to do is we need to import the DXF file. And you can do this by going to the File menu, Import, and you can go to Import Vectors. And then you can go ahead and select the cat head 1/8 inch DXF file. Okay, so here are the pieces and that they give you, and everything is set to 1/8 of an inch. So the first thing I want to do here is I like to center everything in my workspace just so I can see it here. So we're going to click the Align tool and Align to Material. That's going to move everything nicely to the center. You may see my zooming in and out appear fast quite a bit. That's my magic mouse on my Apple that I'm using, and it's a little sensitive. Now, again, what's important here is this file has been scaled to 1/8 of an inch. So what that means is that they're counting on the thickness of each of these pieces to be exactly 1/8 of an inch thick. And when this side piece is standing up in this slot, the face of this should be even with the face of the wood here. So if we use the measuring tool and we zoom in here, we can see that this is exactly 0.125 inches deep right here. Okay, the reason I mention that is because not every piece of wood is the same thickness. And even though they say it's 1/8 of an inch, it may not necessarily be 1/8 of an inch. For example, this particular piece of wood, when I use a digital caliper on it, is supposed to be 0.125. It's actually 0.121. Now, why that's important is if the material is smaller, is thinner than what you've got this job scaled to, then this outside surface is going to match up here, but you're going to have a gap on the inside. The puzzle just won't fit together as nicely. And on other pieces that have a keyhole in the center that you're putting something in, if your wood is too thick, then it won't fit. So that's another thing to be concerned about. I'm always worried more about the material being too thick than too thin. So one thing we can do here is we can scale this job. So how do we do that? Let's see. So this is already designed to 0.125. So one thing we're going to do is we are going to go to stepcraft.us/scale. And this is a simple scale calculator that we've had on our website. You can put in the original material thickness. So in this case, it's going to be 0.125 inch. When they say original material thickness, they mean the thickness that this job has been designed to, that the DXF file is scaled to. And then the desired material thickness is the actual thickness of our material. I will change probably these in the future to be a little bit more clear on that. So we're going to do 0.121. And then we click calculate. And that's going to give us a scale percentage of 96.80. So we're going to copy that. Then we're going to go back to Cut 2D. And what we're going to do here is we're going to select everything. And then we're going to go here to this transform object is the second icon in. When you hover over it, it says set selected object size. We're going to click that. And you can see here, first thing we want to do is we want to make sure that X and Y are linked together. And this is going to tell you that this is the overall width and height of what has been selected. And you can see that's at 100%. So what we're going to do is we're going to select 100%, and then we are going to right click and we are going to paste our new value in at 96.8%. And you'll see what it did was it actually made the width and the height a little bit smaller. When we click apply, you'll see the entire job scales just a little bit. Now, so let's look at what happened here. If we click on the measuring tool again and we click from this corner to this corner, you will see that the new size is now 0.121. So when I put my piece, when this piece goes into here, it'll now be perfectly flush to the side. And the other thing too is that it also scales the height of the tab as well. So from here to here right now is 0.363. So if we were to look at this from here to here, you'll see it also says 0.363. So that's an easy way to scale your entire project down to match your material thickness. Okay, so the next thing we have to look at here is we do not, like I said in the beginning of this video, we do not cut square corners, square inside corners with a CNC. And so what's going to happen is we're actually going to cut a corner that's going to have a small radius. So if I were to create a diameter right here of 0.125 inches, because I'm going to use an 1/8 inch end mill to cut this. So that would be 0.125. So this circle represents my end mill. And you could see that that is as far as my end mill can get into the corner. So we won't have a square corner. We're going to have a rounded corner leaving material right here. And that's going to be a problem for the fitment of the parts. When you go to slide the side piece into here, it's probably going to stop somewhere around here because you can't push it in any further. So what this just gives you an idea what the end mill is. Now what this will actually look like if I were to fillet this corner, this is the actual cut path that would happen with an 1/8 inch end mill. So you can see it's no longer square. That's what you would end up having. So you'd be trying to put a piece that has a square corner in here, and it's just not going to fit. So what we can do here is we can create dog bone fillets. And that's pretty easy to do. In Vectric, you can click this button here. It's the fillet object tool, and we're going to click that. We're going to put in the tool radius, not the diameter. So I'm going to use an 1/8 inch end mill. So I got 0.0625, which is a 1/16 of an inch set as my tool radius. I've got two different types of fillets that I can do here. I could do a dog bone fillet or I could do a T-bone fillet, and it really is personal preference as to what the final output looks like. If I were to select a dog bone fillet, what's going to happen is you'll see it's going to notch out that corner by the diameter of the end mill. And if I do it on this side, so what it looks like is it looks like part of a dog bone. That's why they call that. The other way we could do this is we could use a T-bone fillet, which is going to basically notch it like this. I don't personally like the T-bone fillet because it leaves too much material open here, and I would rather use the dog bone, and that way I have a little bit of material here and a little bit of material here. So we're going to change this over to a dog bone fillet, and that's what you end up seeing. Now when I go ahead and I put my my piece in here, you'll see now that it will fit perfectly because the corner will now, it's cut away, so that side piece is going to fit in without any problems at all. So we're going to go ahead and delete that square I just drew. And now what we need to do is we need to go around and we need to do a dog bone fillet on all inside corners. So we're going to have to do them here. Again, on the tab, we have to do this because if we don't, the same thing will happen. You won't be able to push this piece down and you'll end up with a gap under both sides. So we're gonna do this. We have to do these here, this one here, and let's see, we got these here, this one here, and that should be it. So now everything has got fillets on it. Some of the MakeCNC.com puzzles are already filleted, which is nice. This particular one wasn't, which is actually good because I get to show you how to do it. Okay, so the last step here before we create a tool path is I don't want to cut this out right now just like this, how this is laid out, because if I do, what's going to happen is I've got a lot of waste material, and it doesn't, why throw away all that material? I could almost make two of these projects in this same space. So what I'm going to do on the Pro version of Cut2D and the Pro version of VCarve, they have an auto nesting feature, which is kind of nice because you could just select everything, tell it your tool diameter, tell it how far you want to space the parts, hit one button, and it arranges it automatically for you. But unfortunately, we don't have that here. So what we're going to do is we are going to have to manually kind of nest things a little bit. So what I'm going to do here is I'm going to take this part here, and I'm just going to highlight it and then double click it, and you'll see all these handles that appear. If you put your mouse over until you see this icon, you can click down and actually drag it around where you want it. So I'm going to move this into the corner, and then I am actually going to move this piece in next. But what I want to do is see how this is kind of U'd out here and this is bumped up a little. I'm going to go ahead and I'm going to use the rotate command. So that's this button right here. And I'm going to say I want to rotate this by 180 degrees, which is essentially going to flip it upside down. Then we're going to, same thing, we're going to hold it and drag over here. And now I've got that right on top of it. We're going to click this piece here, and we are going to, let's see, we're going to rotate this one 90 degrees and click apply. Now, sometimes you may not want to, on puzzle parts, you may not want to rotate them 90 degrees. And where that you have to keep in mind is if your wood grain is going up and down, then you may want the wood grain to be going in the same direction on all pieces. In this case, I want it to go in the same direction on the front and back and sides, but I don't necessarily care what direction it goes on the bottom because it's the bottom. So we're going to take this piece here, and we're going to double click it and move it, and we can probably fit that here. And then what we'll do is see if we move this up like this, we could probably get this piece, yep, right in there. Perfect. So now you see I've nested this, and I've what I'll do is when I cut this out, now I know I have this space for other parts or something. I could put this piece of material back on the CNC and use it for something else later. So now I've got my parts all laid out. This is how I want to do it. And now I'm going to create a toolpath. So I'm going to go over to the toolpaths tab here, and you'll see this slides out. I'm just going to click on this button here, which is the auto hide. That's going to pin this window open. I like to work that way because I like to have both sides open so I can manipulate my work as I'm doing it here. So what we'll do is we'll select everything. So start in the upper corner, hold your mouse down and drag so everything is highlighted. And then we will go ahead, and since everything is dashed purple, that means that it's currently selected. So we're going to go over here, and all we have to do, there's several toolpaths here in Cut2D. There's the main ones are a profile and a pocket, and then of course there's an engraving and an inlay, and then a drilling toolpath. But this is a pretty simple project, so all we have to do is worry about the profile toolpath. So we're going to click on that, and there's a lot of stuff here. I'm going to try to make this as simple as possible. Our start depth is the top of the material, and our cut depth, because we said the material thickness is 0.121, we're going to make this cut depth 0.121. Now, here's something that's important to remember. When we set this up, we're going to put a piece of sacrificial material underneath it. We call it a spoil board. Usually it's not, doesn't have to be too thick in this case, but I think I have a piece of 1/4-inch plywood that I can lay underneath this job when I fix it down. And the reason for that is because I actually want to cut all the way through the material. If I only cut 0.121 and there's any deviation in the thickness of this material between the starting point down here and the finishing point up here, you might find that some parts are not cut out all the way, and then you've got to go back in with a razor blade, cut them out, and then sand them. Since I have a CNC machine, I don't like to sand if I don't have to. So what I usually do is I usually go 0.010 deeper than the material actually is. So in this case, I will go 0.131 for my depth. And what that's going to do is that's going to ensure me that I cut all the way through, and it's going to ensure that I'm actually cutting into the spoil board a little bit, but I will have a nice clean top and bottom cut on these parts. So now we have to select our end mill. So if you click the select button here, you'll see that Vectric has a bunch of end mills already in here You can also create new end mills if you'd like. Fortunately, this again is the simple project. The 1/8 inch end mill is already in there, which is a pretty standard end mill in North and South America for size, especially in the United States. So we're going to select that. You'll see the diameter is 1/8 of an inch. The pass depth is usually set to half the diameter. That's a pretty standard rule of thumb, especially when you're beginning with a CNC. Step over is only used when we're doing pocketing, and in this case, since we're not pocketing anything, we don't have to go over that right now. Spindle speed RPM, if you're using a computer-controlled spindle that's like the HF500, then you could put in your RPM here. I would most likely do this around 12,000 RPM. However, if you're using a manual spindle like a Crest, a DeWalt router, or MM1000 spindle, or even a Dremel tool, you can adjust the RPM manually using the dial on the spindle. Now, the feed rate is set to 20 millimeters a second. Since these parts are pretty small, I'm going to really slow this down. We don't necessarily need to. 20 millimeters a second is perfectly fine for this thick of material on any of our machines. But just for the purpose of the fact that I don't want to have any of these parts nick and fly out, I'm going to slow it down a little bit. And our plunge rate, which is the speed that the bit enters the material vertically, we'll leave set also at 10 millimeters a second. Tool number is only if your machine has a tool changer. In this case, we don't have one on this machine, so we're going to leave it at 1. I'm going to click OK. And you're going to see over here that it's going to say that it's going to take 2 passes to cut all the way through this material, which makes sense. We set it to a 1/16 inch per pass. It rounds up, which is nice, so it actually won't do this in 3 passes, which is good. Now, the next thing is we've got to determine where we're going to machine our vectors. Now, basically what that means is whether we are going to cut outside this line, inside the line, or on the line. Now, if we cut on the line, this part will be 1/8 of an inch smaller, or actually a 1/16 of an inch smaller all the way around, but 1/8 of an inch in total, left to right and vertically. So we don't want to do that. Usually on the line is used for when you're using an engraving tool with a fine point, or like a STEPCRAFT drag knife or a wood burning pen, where you actually want to make the tool run exactly on the line. Inside the line would be great if there was a hole in the center here. Then I would want to cut that hole out inside the line so it maintains that diameter. But in this case, everything we're doing here, nice and simple, we're going to cut outside the line. And we're going to do this with a standard conventional milling, which basically the end mill is always spinning in clockwise direction, and a conventional also moves in a clockwise direction, whereas a climb milling, if you were to select that, it actually moves opposite the direction that the end mill is spinning. So the end mill is spinning clockwise, but we're going around counterclockwise. In this case, for this plywood with the bit we're going to use, I'm going to go in a conventional format. Allowance offset we won't worry about in this video. Do separate last pass, same thing, we will not worry about that. Add tabs to toolpath. Well, remember I said some of these pieces are really small, and the last thing we want is for the end mill to catch it and then have it go flying out of the machine, or worse yet, it gets stuck and it breaks loose and it vibrates between the hole and the end mill. It'll end up ruining the edges. So what we're going to do, we have a couple options. We could put a couple strips of double-sided tape down this project and stick the material down, and then what'll happen is as you cut through the part, you'll actually cut into the tape, and when you remove the scrap material, the parts will be stuck down using the tape. So that's one way to do it. If you don't have double-sided tape and you just want to clamp this down, maybe using the built-in STEPCRAFT clamps, you can add tabs to the toolpath, which I'll show you how to do now. So we click Add Tabs to the toolpath. The tabs can be pretty small on this part because it's a small part. So we're going to make them 1/4 inch in length, and to make them 1/8 inch thick would be the full thickness. So we're going to actually go 0.0625. So we're going to make the tabs a 1/16 of an inch tall. And then we click Edit Tabs. So now what we need to do is we need to indicate where we want the tabs to be on this project. So I like to put tabs on straight edges. Like I wouldn't want to put a tab in here and here, because later you're going to have to sand it off. And it's going to be really, you don't want to put the tabs in a place that's going to be difficult to sand them. So I like to, you know, like on this piece, I might put one here, and probably one over here. The other thing you want to keep in mind is like I wouldn't want to put a tab here directly across from another one. So I usually try to space them out. So there's a void area here, so that's a good place for a tab. There is nothing over here, so these three are going to be okay. Let's see, on this big one here, we could actually put the tab right on the corners because they're straight. And then we need one more. Maybe what we'll do is we'll put a tab here and here. And then we'll put a tab here and here for that piece. And let's see, maybe we'll do the same thing. We'll do the corners here and here and here. So now we have tabs. So this is going to assure that when we're cutting, these parts don't break free of the material. Ramps, leads, orders, we're going to ignore this section for right now. And the last thing you have to do is just give this a name. So we're going to call this cat cutout. And we're going to click calculate. Now a window is going to come up. Remember, we set the material thickness over here to 125 or 1/8 of an inch. And we told the tool here that we're going to go down 0.131. So it's okay. It's just warning you that it's going to cut all the way through the base of the material. And if you don't have a spoil board in there, you could possibly damage the machine bed. So we don't want to see that happen. So it's asking you, it's reminding you should put a sacrificial layer under the material. So we click OK. And now you could see that you see these blue lines. That's the tool path. So that's where your tool is going to actually run on the CNC machine. So what we're going to do now is we are going to click on, make sure this is selected and checked. We're going to click on Preview Selected Toolpath. This is a really cool feature with Vectric. When you do that, it simulates where the tool is going to cut. And you can actually rotate your material, so you can look at the bottom, you can look at the side, so you can see it's an 1/8 inch deep. You can see that we have the tabs here that are cut. They're 1/4 inch long and they're cut through half the material. And you can see our dog bone fillets all the way around. So this is actually pretty good. Now I do see one potential problem. Right in here, when we cut here with this, you'll see this is this little piece is probably gonna fly out of there because it's gonna break free and it's not held in by anything. So that's potentially going to be a little bit of a problem here. What we could do is we could rearrange the parts so that that doesn't happen. But one quick fix, it'll require like a second or two of extra sanding, is we could just add one more tab. So if we go back and edit that tool path, we could just add a tab right here and then close. So that'll break free, and then we'll get in there with a small sanding or a file and we will get rid of it. So if I reset the preview here and then select preview selected toolpaths, now you can see that little piece is actually trapped in there and it will not break free on its own, which is good. It's so small that if we didn't have the tab there, I don't think it would be a big deal. It would just kind of fly out of the way as long as the part is held in place with the tabs on either side. So there you have it. That's now we're ready to get over to the CNC machine and cut this thing out. And then when we're done, we'll just take a razor blade and we'll score along the edges here to cut the tabs off and maybe hit them with a little bit of sandpaper and it'll be perfect. Again, if you have double-sided tape, you can run a few strips on there and then you don't have to worry about tabs at all. So that's really up to you and how you're setting up this job. So the last step here that we have to do is we have to take this tool path and we have to output it so that it can be run on the CNC machine. So what we're going to do is we're going to click check the tool path for the cat cutout, click close, and then we're going to click on this disk icon. It's called Save Toolpath. When we click on that, we're going to see there's a huge list in here of all the different CNC manufacturers that Vectric works with. But you're going to want to look for the STEPCRAFT ones. And you'll see that there's really two different types here. There's a STEPCRAFT UCCNC ATC ARCS. ATC stands for Automatic Tool Changer. So if your CNC has an automatic tool changer, then you can select this post processor. However, if it doesn't, like ours won't, then we will select this post processor, which is just the ARCS, and it's in millimeters. Now that brings up another good point, because a lot of people ask that. UCCNC requires that we input the file in metric and not imperial dimensions. Now you notice that when we set this job up, we set it to 12 by 6 inches, an 1/8 inch thick, and we brought in a DXF file that was also an 1/8 inch thick. It was set up for that. So, you know, a lot of people will ask us, geez, I don't want to work in millimeters. Well, that's the cool thing about Vectric and this post processor that we wrote. You don't need to. So you can design in inches, and then as long as you select this post processor, Vectric will actually do all the work and calculate all of the inch dimensions and everything over to metric automatically. So you don't ever have to worry about using metric if you don't want to. So what we're going to do lastly is we're just going to click Save Toolpath to File. I'll just save it on the desktop. We'll call it cat cutout, and now we're done. We'll take that cat cutout file over to the CNC, and we will go ahead and cut this thing out.